You guys to be happy to be here and want to get college credit.
Now I'm happy to be here. Now that I'm starting to You're actually hilarious.
All right, guys. So this is review number one. So the next one I'll call review two. It's over differential equations, and you're going to notice we have four questions here that are differential equations. None of them require a calculator, and I put one contextual one in here. Those of you that were here for Saturday Starbucks, you'll recognize one of the problems. All right, let's start with this one. Let's go right into it. This is from 2008, FR5, no calculator. All of these are no calculator. Number one, it says consider the differential equation dy dx equals y minus 1 over x squared, where x does not equal 0. On the axis provided, sketch a slope field for the given differential equation on the 9 points indicated. They're lattice points, but it's not a big deal. Do not see how it says x squared? There are no lattice points on the y-axis, so do not do that. You will get a penalty. If it's undefined, do not write anything. You only put little segments on the points that you see. All right. If y equals 1, do you guys see how that slope would be 0? So we just put a slope of 0 on all the y equals 1s. Are we still okay? All right. I'm going to hold x equal to 1. And I'm just going to, so I'm looking at this one right here at 1, 0. And I'm just going to plug in. I know. I already turned off one of them. So if I plug in a 1, 0, negative 0 minus 1 is negative 1 divided by 1 squared. That's going to be negative 1. So put a slope like that. See? And if I'm at 1, 2, 2 minus 1 is 1, and a 1 divided by 1, there it is. I'm going to x equals 2, so I'm at 2, 0. So if I plug in a 0, 0 minus 1 is negative 1, 2 squared is 4, so I'm going to have negative 1/4. It doesn't have to be perfect, guys, just make it less steep than the one over here, so negative 1/4. See? Negative 1/4. And now I'm at 2, 2. 2 minus 1 is 1, and then 2 squared is 4. So what's that? Positive 1/4. So just make sure it doesn't look like 0. So as long as it doesn't look like 0 and it's not steeper but flatter. Hopefully I didn't say steeper on the last one. Are we still okay? All right. Now I'm at negative 1, 0. So 0 minus 1, that's negative 1, and then negative 1 squared is going to be. So my total thing is going to be negative 1/4. So make it look like the one at 2, 0. Make it look like this one. Make it look like that one. 2, 0, not negative 1, 0. Sorry. Am I wrong? 0 minus 1 over negative 1 squared. Oh, yeah. I'm dumb. Yeah, you're right. But, yeah, we should not say that. Don't say that stuff. All right, there we go. And then the one at negative 1, 2, that one's going to be a positive 1. And I think we're good. Hopefully there's no mistakes. Let me know. What's up?
How many questions are there around these?
I don't know, but total. Let me see what percentage. 20% of the exam. Oh wait, 12% of the exam. 12%. Probably unit 6, 20%. I think we got it right, guys. All right, here we go. Find a particular solution to the differential equation with the initial condition f of 2 equals 0. All right, so that means that I have this as my initial condition, or a condition, and my first move, so write dy dx equals y minus 1 over x squared. They want you to solve for an expression or an equation. So what's my first move? Yeah, x is with the x's, y with the y. So you're going to have dy over y minus 1 equals 1 over x squared dx. I guess put the dy to the side here. Like that. Are we still okay? Okay. What's my next move? Integrate. Bam. Bam. So that's going to be, this is a linear expression on the bottom. So this one's going to be ln absolute value of y minus 1 equals, this is not a linear expression, so do not call that ln. That's x to the negative 2. So add 1, x to the negative 1, and divide by that number. So negative 1 over x plus c. Yes.
For the ln, how do you know to put absolute value?
If there's no limits, put absolute value. You know what? You brought up a good question. So how do I? This is a side note. Don't write anything down. Just listen. How do I know when I put absolute value on this, and how do I know when I don't? Well, if I told you the expression 1 over x, this is just for notes, guys. This is just side notes. 1 over x has domain all real numbers except 0. And ln of x does not have domain all real numbers. Ln of x has the domain is all numbers larger than 0. So if I want the domain to match the same as 1 over x, you put an absolute value. Because now, if I put an absolute value, then it turns to all real numbers except 0 as well, just like 1 over x. Does that make sense? So that's why we put the absolute value in there. Okay, that was just for notes or for. I wouldn't write that anywhere in there. Okay, let's see where are we at. We're here. I have the habit, and this is just me. Everyone's different. I have the habit of finding my c immediately, so I plug it in immediately. So ln absolute value 0 minus 1 equals negative 1/2 plus c. ln of negative 1, the absolute value of negative 1 is 1. So, and the ln of 1 is 0. So your c is 1/2 when I move the negative half to the other side. Are we still okay? All right, so I'm going to write ln absolute value y minus 1, close it, equals negative 1 over x plus half. Are we still okay? All right. I want to bring the y minus 1 down, so what am I going to do? E. Whatever you do to 1, you do to the other. So I have absolute value of y minus 1, close it, equals e to the negative 1 over x plus 1/2. We're close. We're close. We're still okay? I'm going to get rid of the absolute value. I'm going to put all this in parentheses. This is, well, that's an exponent, so it would have been fine. So I'm going to do this. Y minus 1 equals plus minus e. I guess you don't need the parentheses because I don't have anything like floating over there. Chav, why did you do that? Remember that absolute value of x is equal to plus minus x. In a little bit, we're going to determine whether it's a positive 1 or the negative 1. We're going to let the condition tell us. Move the 1. So y equals plus minus. The plus minus is only for the e. Negative 1 over x plus 1/2. And then when I move that 1, it's going to be plus 1. Now, which one do I choose? Do I choose the positive or do I choose the negative? Well, let's find out. When I plug in a 2, I better get 0. So let's see. If I plug in a 2 up here for my exponent, so here I am. I'm zooming in right here. So that will turn into a negative half. Negative half plus 1/2 is 0. E to the 0 is 1. But in order for it to equal up to 0, I need to choose the negative 1. See? So negative 1 plus 1 is 0. So there it is. I chose the negative 1. And I would write one more sentence just to I guess you can probably get away with this by circling that. But I would just do it just in case like this. And then make sure that plus 1 is not floating. How do we feel? Okay. And then letter B, they're just checking to see if you know limits. I guess we'll go slow with this one. It says, find a particular solution described in part B as x approaches infinity for f of x. This is my f of x. So before I even do it, I'm just going to do this. Limit as x approaches infinity. And I'm just doing it for that right there. Negative 1 over x. So as x approaches infinity for this, what is this limit? Negative 1 divided by something big. 0. Oh, because I wanted you guys to know that expression right there is like a 0 then. The 1 over x. Really, they want this. Limit as x approaches infinity for negative e to the negative 1 over x plus half plus 1. They want that, right? But I want you guys to see that this guy is a 0. So then that means this one that I'm circling is like 0. So I have negative e raised to the 0 plus half, which is just negative e to the half plus 1. There's an answer. I haven't looked at the rubric yet. Well, I mean, I did at one time at least, but I haven't looked at it yet. What year was that? 2008. So let's look at it real quick, guys. It won't take more than a few seconds. Did you guys like that question? Did you guys not like that question? Okay. What year was it again? I already forgot. Short-term memory? 2008. Okay. So here it is, question 5. Let me zoom in. So 2 points for the first part. You okay, Miss Kyle? Breathe. They gave you a point for the 0 slopes, and they gave you a point for all other slopes. So there it is. Does mine look like theirs? Yeah. Look at letter B. How many points there was? Look at the notes. Can someone read the notes? The very bottom, the second note especially.
No separation of variables.
If you don't separate the variables, you're not gonna get any points. Now, if you're like, man, I don't know, Chop, if I can get the answer, the algebra. Look, relax. It's only 1 point for the algebra. If you might be able to get the other points, look, 1 point for separation of variables, 2 points for antiderivative. So did we get the correct antiderivative? ln of absolute value y minus 1, negative 1 over x plus c. It looks like they solved for y first, and then they solved for the k. It's not a big deal. See, this is how the rubric for that they have. We got the correct answer, and here's my f of x. 1 minus e to the half minus 1 over x, as long as that's greater than 0. They'd like for you to state the domain, but you don't have to. Did we get all those points? Yes, we got them all. Ask me.
How did they get 1 minus square root e?
Oh, that's the same thing. What's the exponent of a half?
Oh,
Square root. You know what I mean? There it is. Did we get the same thing for letter C? Yeah, 1 minus square root of e. That's the same thing as negative e with the 1 power 1 half plus 1. There it is, guys. We got it. We got all the points. 9 points. Let's keep going. Let's see how number 2 here.
Wait,
What? Yeah. Hit me.
So you would say whenever we're finding a particular solution, it would be easier to find C first, right? So
I think it is. Maybe by the time you hit up your university, your professor's going to be like, find a general form and then find in. I think it's easier to find for C immediately. I think. It depends. In years past, I've gone softer throughout the years, but in years past, I would tell kids like sometimes solve for C first, sometimes do it at the very end, depending on what type of equation it is. Now I'm just like, just get it right off the bat. You know? All right, here we go. Another one, no calculator. Let's see what letter A says. A slope field for the given differential equation is shown below. Sketch a solution curve that passes through the point 0, 2, and sketch a solution curve that passes through the point 1, 0. I think I graded this one. Pretty sure I did. Pretty sure I graded this one. I remember something along the lines of the rubric saying that the solution curve must pass through the whole curve, through the whole graph. Okay, the one at 2, 0. If I go through that one, what type of line is that going to be? Horizontal line, a linear line. Look, there's nowhere else for it to go, guys. Does everyone see that? All right, if I pass through the point 1, 0, you got to follow this. This is like currents. Let's see. There it is, perfect. And we're not looking for perfection. Follow the lines. There it is. Do you see how we did it? Just follow the lines. Those are like currents, like wind currents, like water currents. All right, here we go. Let y equals f of x be the particular solution to the given differential equation when initial condition f of 1 equals 0. So there it is. That's my coordinate, 1, 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f of 0.7. All right, I want a tangent line. What 2 things do I need for a tangent line? Point and slope. So don't go looking for f of x. Don't do separation of variables or any of that. They're not asking for that. Point. Yeah, they just say what's my tangent line, and then use that to approximate. So here it is. I got my point. I need my slope. Look, you have dy dx right here. So you're going to go dy dx, that's your slope, evaluated at 1 comma 0 equals 1/3 times 1 times parentheses 0 minus 2, close it squared. All right, let's see what that is. 1/3 times negative 2 squared is, so my slope is 4/3. Are we still okay? All right, here's my tangent line. Y minus 0, so you can just leave it like that, equals 4/3 x minus 1. And I know some of you are tempted to distribute that 4/3. You can if you want. But I think it's, you don't have to. And 2, I think it's easier to leave it like that and move that 0.7 right there. Because that's what you want to approximate, right? So I'm going to write f of 0.7 is approximate. You don't have to write the approximate symbol, guys. You can write equals if you want, but approximate symbol is better. 4/3, parenthesis, 0.7 minus 1, close it. If you are prone, bless you, if you are prone to getting these wrong, leave it, especially if you just want the point. Now, we're not teaching to the test. Oh, I guess we kind of are by telling you to leave it, but we're not teaching the test. I encourage you to continue. Now, after mock exam 2, if you keep making arithmetic errors, I will give each one of you a personal letter, so because that way none can read like whoever, right? So no one gets offended. If your personal letter says leave alone, that's so you can get your, you can get yours. Don't get offended by that. I just want you to pass and qualify. All right, here we go. Let's continue. I think we're good. 0.7 minus 1, that's a negative 0.3. Negative 0.3 is the same thing as saying negative 3/10, right? And then look at this. Those 3's cancel out. And what is 4 over 10? Negative 2 over 5 or negative 0.4. Whichever one you like. How do we feel?
So I was going to ask a question on the sketch. Do we have to make it continuous at the endpoints? Or?
No, just as long as it passes through the whole thing. You could, like that one for sure looks like that, but you're fine. What's up? Oh, you're good. You don't have to simplify. You don't have to simplify, but I encourage you. But if you're like, oh, I'm scared, you can leave. All right, here we go, guys. Find a particular solution to the given differential equation with initial condition f of 1 equals 0. Okay, now they want y equals something. So I start with my differential equation. So let me see. Do I have it here? dy dx equals, what was it again? 1/3 x y minus 2 squared. Okay. What's my first move? You get a free point just to separate. So here it is. Divide, the y minus 2 stays together with the square, and then multiply by the dx. So here's what I'm going to have. 1 over y minus 2, close it squared, dy. If you want to put the dy in the numerator, that's fine. 1/3 x dx. You can actually move that 1/3 if you want, times 3, but I'm going to leave it like that because it's not bothering anyone. Are we okay? What's up?
Why do we plug in a y minus 2?
Oh, because I'm putting the y's together. You know what I mean? So this is a product, so I had to divide to move it to the left. Ask me. What happened?
We integrate.
Yes. What's my next move?
Integrate.
By integrating, you get rid of the differentials. That's how we get rid of it. So here we go. Hopefully we're good enough, guys, that we don't need to do u sub on the left. But if you need to do u sub, that's fine. Negative 1 over y minus 2. Yeah. Do you think we need to do u sub? No. We can if you want. Equals. You can if you want, guys. You don't have to do u sub, but you can if you want.
It's a linear line, so we just use.
Well, this is 1/3 x. The x is in the top. Bless you squared. So add 1, divide by that number. So here's my 1/3. That's that constant. Times x squared over. No. It would be 1/6, right? Because we're adding 1 divided by that number. And when you take the derivative, you better get 1/3 x. Are we still okay? All right. Negative 1 over y minus 2. I'm just making it pretty. Equals 1/6 x squared plus c. I haven't done anything crazy. I like to solve for it right here. You saw the last FRQ, how they solve for it at the end. It doesn't matter, whatever you're most comfortable with. I'm going to plug in my 1, 0 already. So if I plug in my 1, 0, negative 1 over negative 2, because 0 minus 2, equals 1, 6, parenthesis, 1 squared plus c. Are we still okay? Negative divided by negative is a, yeah, sorry, I can't talk now. 1, 6 plus c, so I'm going to move the 1, 6 to the left. So 1 half minus 1, 6. So we're going to have to do a little bit of arithmetic. Relax, it's not extreme. Times 3 over 3. So this turns into 3, 6 minus 1, 6 equals c. 3 minus 1 is, so this is 2, 6, which is the same thing as, so 1/3 equals c. Now we're going to come back right here to that one. Do I have space? I have space right here in the top border, so hopefully you guys wrote small. Sorry if you guys didn't. Negative 1 over y minus 2 equals 1 6 x squared plus 1/3. Now, okay, I'll stop here. I haven't seen this rubric. At one time I did. I haven't seen it. I'm going to take a guess that they probably did all this over 1, which I'm not a fan of. I'd rather find a common denominator, but I think they probably have this answer. So I'm going to put that all over 1. Are you guys okay with that? Okay, I have a fraction. I'm just going to flip. So here's what I have. I still have that negative, and then parenthesis y minus 2, because I haven't distributed the negative, guys, equals 1 over 1 6 x squared. You can put the x squared in the numerator if you want, x squared over 6, plus 1/3. Are we still okay? I'm going to get rid of that negative by moving it to the other side, or multiplying by -1 or whatever you want to call it. So I'm just going to erase it and put it right here in the front. You can put it next. You can put it in the top if you want. So now I'm going to get rid of this parentheses. What's my last move? Move the 2. This is not my favorite, but I'm assuming they're probably going to have this answer. There are other answers. Plus 2. Maybe put f of x. Let's look at the rubric. Are we okay? Hey, you haven't yawned today, miss. Wow. Is that demerit?
It's because I got a demerit.
I gave her a demerit. Yeah. Not a, yeah, I gave her a demerit. Sorry, Montalongo, if you're looking at this video. I don't know if she's looking at this video. Yeah.
Time in class. And talk smack.
I have the original. I'm going to staple it to the simulator.
I didn't know you had to write stuff.
Yeah, I have a whole bunch because I write a whole bunch.
How does John have demerits?
All right. Here we go, guys. Letter A. Did I get the 2 points? So it's looking like anytime we have one of these, you get 2 points there. And look at the note that they give us. Curves must go through the indicated points, follow the given slope lines, and extend to the boundary of the slope fields. Yesterday, when you guys were doing delta math, you weren't extending it, and that's why I was counting it wrong. You have to extend it through the whole thing. Cool or not cool? All right. Letter B. They give you a point for the equation of tangent line. Did we get y equals 4/3 x minus 1? And 1 point for the approximation. Did we get negative 0.4? There we go. Anytime, see this, it's always so many points. Anytime there's a differential equation, look how many points they give you for that. They give you 5. They give you I think it's a free one. They give you a free point just to separate the x's with the x's and the y's with the y's. Get your free points. What a free point. Let's separate the variables. You separate the variables, x's with the x's, y with the y's. And I know some of you are so paranoid, you're like, you write the thin line again, like, my y's over my y's, my x's over my x's. I'm going to do another line. I'm put it in integral. Guys, you can just put the integral immediately. Not a big deal. It's already separated. X's with the x's, y's with the y's. There's my integral. And let's check it out. And then let's see. Did they solve for c immediately? Okay, see, they're bipolar. Last problem, they didn't do it until the very end to solve for c. On this problem, they're doing it immediately. It just depends. See? I just said, just solve for immediately. Did we get 1/3 as our c? Yeah. There it is. And... okay, they did keep change flip. They actually did find a common denominator. See, sometimes they do it, sometimes they don't. This is equivalent to our answer. It's the same. Child, I don't believe you. Okay, let's go to ours really quick. Look, where's our answer? So you see this 1/3? I'm gonna turn that into 1/3 times 2 times 2. 2, 6, and then that becomes x squared plus 2, and then keep change flip, that 6 goes to the top, and then I see even numbers everywhere, and it reduces to, that's equivalent to that. See, there it is, 6 over x squared plus 2. You guys see that, right?
Yes.
Okay. Cool or not cool? All right, so we got them all. We got all the points. Okay, don't worry, miss. We're almost done. We're halfway. All right, here we go. Do you guys think you guys are good enough that you guys want to try and see if you guys can tackle one on your own, and then we'll come back together? Yeah, try to see if you guys can tackle the 2006 one. Work together, guys. Maybe we'll call one of you guys up.
I nominate Jocelyn. You better not do that. I nominate Jocelyn as student.
All right, guys, come on. Let's focus. Ask me, miss.
If we get one of the points wrong, is it all?
They probably, I'm going to assume like the other two rubrics, you know how they've been giving you 2 points? I'm going to assume they give you 1 point for the zero slopes and then 1 point for the others. Now, I don't remember because I don't remember this rubric. Obviously, I looked at it at one time, but that's what I'm assuming from looking at the other two rubrics. I'm going to start with letter A, guys. Maybe you guys already finished. I'm not sure. I know that I have zero slopes whenever y equals. So zero slope, zero slope. Let's see, at what point? Negative 2, 0? Negative 2, 0. Let's see. 1 plus 0, and then negative 2. Yep, negative 1/2 on this one, so make it look like that. And then on this one, negative 1. And then at 1, 0, that's going to be a positive 1. And then at 2, 0, that's going to be a positive half. Does everyone have that on the x-axis? Okay. And then at 1, 1, 1 plus 1 is 2, divided by 1, that's going to be 2, so make it look like that. And then at negative 1, 2, negative 1, 1, negative 2. Did I do that right, guys? Okay. Does y'all's look like that? Okay. I don't know. It just depends. I know that I have vertical asymptotes right here. Maybe something like that. But they're not asking that, you know? But, okay. Probably has a vertical asymptote. Probably. All right. Well, we're about to find out because look, we're about to find the expression. Find a particular solution. Y equals f of x is a differential equation with initial condition negative 1, 1. So I'm to the left of this. So I'm going to negative 1, comma 1. And we're about to find out the expression. Let's see how it looks. So dy dx equals 1 plus y over x. So how do I get my first point? Separate the variables. Y is with the y's, x is with the x's. Let's see, divide. So 1 over 1 plus y dy equals 1 over x dx. What's up?
I have a question. How do we know whether to put everything under 1 or to put everything over?
You can put the dy in the numerator, but see, this is in the top. So how do I get rid of the 1 plus y? By dividing. So you have to divide it. How do I get rid of that dx in the bottom here? So I got to multiply it, see? Like this x is in the numerator here, and in order for me to get rid of the 1 plus y, I got to divide by 1 plus y. Whenever you do the one, you do the other. See? You don't see it?
No. Okay. Well, I just went.
Okay.
So it doesn't matter what we do?
Like, okay, De Leon.
Like if I put 1 plus y dy equals x dx.
No, it does matter because it's not 1 plus y in the numerator. It's 1 plus y is in the denominator. Because your initial expression, look, okay, let me rewrite this so you can see it better. You have this, miss. You have 1 plus y over 1 times 1 over x. Do you see that, De Leon? All right. If I want to get rid of this 1 plus y in the numerator, I need to multiply by 1 over 1 plus y, which is like dividing. Whatever you do to one side, you do to the other. Do you see that, De Leon, or no? Okay, you're not just saying that just to say yeah? Okay. And then you see this dx that I have here, Miss Houston? So we got to multiply. So times dx, whatever you do to one, you got to do to the other. Times dx. So there it is. You see? So you see the 1 plus y's cancel out. And I have the dx, and I still have the x in the bottom. So that's how I know the x is in the bottom, dx, and the 1 plus y is in the bottom with the dy. Did I answer your question? Okay. Did we get it, De Leon? You're not just telling me that. For sure. Okay, so we got it. All right, guys, here we go. I'm probably gonna use this space, so that's why I'm deleting it. Oh man, I didn't want to delete that. Add an X down here, right? All right. Yeah. All right, here we go. You guys ready? What do I got to do from here? Integrate. They're both linear expressions. ln, absolute value of 1 plus y, equals ln, absolute value of x plus c. What am I going to plug in? Negative 1 and 1, that's an x. This is a y. So ln 1 plus 1 is 2 equals ln of negative 1, which is ln of 1. When I take the absolute value, are we still okay? Yeah, let me know, because I make mistakes all the time. ln of 1 is 0, so my c is ln of 2. Are we still okay? Okay. So here's what I have. I'm going to come back to this one. So I'm going to have ln, man, they're checking to see if you know all your rules. 1 plus y equals ln of x plus ln of 2. Are we still okay? E.
So then E would be 1 plus y.
Plus minus, oh, you know what? I won't do that. I'll leave it as absolute value. Absolute value of 1 plus y equals, and I'm going to leave it like this. E to the ln absolute value of x plus ln of 2. We still okay? All right. I'm going to use my law of exponents. Yeah, they're testing to see if you're really good with your algebra. What's up?
Why did the ln go away?
Because E and ln are inverses of each other.
I know, but like on that side and on that side.
I put E and E. The ln's haven't canceled out yet. I just, because there's something funny happening with this absolute value of x. We're going to have to see whether it's a positive or a negative. Ask me, where? Yeah, because there's two terms. I'm gonna put them. You could have put them as one, but you got to really know what's going on here. This is the same thing as e to the ln of absolute value of x times e to the ln of 2. Yes or no? Yes. And this e to the ln of 2 is just 2. So absolute value of 1 plus y equals 2 e to the ln absolute value of x. Right now we're going to figure out whether that's a positive or negative. So I'm going to get rid of this absolute value. So I'm going to put, when I get rid of this absolute value, I'm going to put the plus minus where the 2's at. 1 plus y equals plus minus 2 e to the ln of absolute value of x. All right, notice that when I plug in a negative 1, I better get a 1. I guess let me move that 1 out of the way. Minus 1, minus 1. Y equals plus minus 2 e to the ln absolute value of x minus 1. Okay, so get up to here. We're still okay? So I guess maybe you were right, Houston, but when I bring this down, I'm going to bring it down with the absolute value. I can't wait to see this rubric. I don't remember it at all. I really don't. Y equals plus minus 2, and then v and ln cancel out. Don't put x, put absolute value of x. Yeah, I think we can leave the absolute value there because it's safe, because see how it says negative 1 in there? But now I got to choose whether it's a positive 1 or the negative 1. So absolute value of negative 1 is 1, and 1 times 2 is 2. But when I subtract 1, I better get a 1. So it has to be which one? The positive. So y equals 2 absolute value of x minus 1. The 2 is positive, yeah. Because when I put -1, I better get 1. You know what I mean? Because the absolute value is going to stay there for the x. I bet you they might have. We're going to look at the rubric right now. They might have -2x minus 1 for x less than 0. Your eyes are more. Okay, we got one left, and that's it. After this, we're done for the day, and there's no new work. You just got to work on your. Yeah, there's no new work. Just work on whatever you have. All right, what you have here. This is the last one. Do we still have energy? Okay, what you have here is a differential equation, but I want you to notice this is in context. So they can give you a differential equation in context. This is called the contextual question. What's up?
So is it guaranteed that we're gonna get a differential?
You're going to get a differential equation for sure.
For that particular?
I don't know how it's going to look.
Okay, so we're for sure gonna get.
If you don't get a differential equation, you'll get like a contextual question that has some type of related rate.
So is this gonna be like the volume of? Is that what we're doing here?
Well, we're not going to actually find. There is volume involved, but we're not doing like rotation or
Like
anything.
what we did earlier.
Yeah,
Okay.
let's read it. See what's up. Ms. Cruz, do you want to read question 4 for us?
A coffee pot has the shape of a cylinder with a radius of 5 inches, as shown in the figure above. Let h be the depth of the coffee pot measured in inches, where h is a function of the time of t measured in seconds. The volume v of coffee in the pot is changing at the rate of -5 pi square root of h cubic inches per second. The volume v of a cylinder with a radius r and the height of h is v equals pi r squared dh.
Thank you, miss. All right, first question. Show that dh dt equals -square root of h over 5. Before you even start, guys, maybe I should have said this before I even read letter A. What is that -5 pi square root of h? That's dBdt. Look, the volume of a coffee in the pot is changing at a rate. So that right there is dBdt. So dBdt equals -5 pi square root of h. Are we still okay? They're being nice to us. They told us that volume is pi r squared h. They don't have to, but they did. They're probably going to give you this equation. And they said, show that dh dt equals -square root of h over 5. And you're probably looking at it like, man, how am I going to do that? Well, look, they gave you what volume is. The radius is constant. Radius is constant. Chop. Why is that important? Because you don't have to do product rule. I mean, you can if you want, and then drdt is going to be 0. It's going to cancel out that term anyways. But you don't have to do product rule. So look, I'm going to write V equals pi r squared h. And the pi r squared is a constant. So look, and I'll slow down. Don't I have dBdt on the right-hand side here? So what's the game plan? I'm going to take a derivative of pi r squared h, and I'm going to set that expression equal to -5 pi squared of h. Do you see the game plan? All right, so here we are. Remember, the pi r squared is a constant. dBdt equals, I'm going to write my pi r squared. That's a constant. What's the derivative of h? dh dt. OMG, that's what they want me to solve for dh dt. I take this expression, and I'm going to equal it to, there you go, pi r squared dh dt equals -5 pi square root of h. You're done with calculus. All you're doing now is algebra. I'm going to divide. I want to solve for dh dt, so I'm going to divide by dh dt equals -5 pi square root of h over pi r squared. Yes. Cancel out the pi's. Bam, bam. And I know that r is a constant. What is my r? 5. R equals 5. So just plug it in. So I'm going to write dh dt when r is 5 equals -5 square root of h over 5 squared. What's that? 25. How many times, and I know, child, that's not the answer. How many times does 5 go into 25? So there it is. Bam, bam. There you go. dh dt is -square root of h over 5. Did we get what they wanted? Yes. Do you see how we did it? Okay. I'll wait for you guys to catch up. Letter B. Given that h equals 17 At time t equals 0, there's my initial expression, my initial time. Solve the differential equation dh dt equals negative square root of h over 5 for h as a function of t. Okay, so t is like an x and 17 is like a y.
So we're just gonna solve for.
So you're going to solve for it. What's my first move? Separate the variable. The h's with the h's, and well, I guess there's no t, so just move the t to the other side. So here it is. Let me rewrite it again. What's up, Miss Houston? So here it is, over 5. I'm going to divide by square root of h. I'm going to leave the negative there because I think it's easier to deal with on the right-hand side. So I'm going to have 1 over square root of h dh equals negative 1/5 dt. Is everyone okay with that? Okay, here comes a little bit of algebra. That square root of h, that's not an ln, square root of h is the same thing as h to the half, right? And when I bring it up, so I'm just going to rewrite it just so it's easier for everyone. H to the negative 1/2 dh equals negative 1/5 dt. I still haven't gotten rid of the differential. When I say differential, I'm talking about the dh and dt.
So then it's 1/2.
Yeah. What do I do to get rid of the differentials? I do a what? Integrate, and then I do what Houston just said. Add 1 to the exponent. That's h to the 1/2. And I divide by 1/2, which is the same thing as multiplying by. So I'm going to have 2 square root of h. Does everyone know where that square root of h came from? That's h to the half. Equals, what's the antiderivative of negative 1/5?
Negative ln.
I don't know.
Yes, you're right.
Negative 1/5 with a what on the side? A t. I guess you can put an x if you want, and if you squint, it looks like a t. And then I put a plus what? C. I like to solve for c right here. That's just me. That's my habit. Well, now it's my habit now. It wasn't always my habit. I'm going to plug in a 0 for t, and I'm going to plug in a 17 for h. 2 square root of 17 equals negative 1/5 times 0 plus c. Semicolon. C is equal to 2 square root of 17. Are we still okay? I come back to the original equation that where I started from, the initial one right here. So I'm going to write 2 square root of h equals negative 1/5 t plus 2 square root of 17. And I'll slow down. Remember what we're doing? We're solving for what? H. So I got to get rid of the 2. So how do I do that? Divide by 2, divide by 2, divide by 2.
So can we just.
Yeah, you can put one big line over 2, but I like to do it like this. So square root of h equals negative 1/10 t plus square root of 17. And then we square all of it. Squared, squared. Do not expand. Leave it like that. H of t equals, parenthesis, negative 1/10 t, or you want to say t over 10, plus square root of 17, close it, squared. You don't have to say h of t, you could just say h. I just have a habit of, it's h with respect to t. Are we still okay? Okay.
So h is 0.
Yes. You're getting ahead. You're getting really ahead. Letter C. At what time t is the coffee pot empty? The coffee pot is empty whenever there's no coffee. And if there's no coffee, h is 0. So that means I take that expression that I just saw for and equal it to 0. The only way that will be 0 is if the inside is 0. So I'm going to go, I guess you can say initially h of t equals 0 like that. And then just set the expression on the inside equal to 0. So negative 1/10 t plus square root of 17 equals 0. Is everyone okay with that? Move the square root of 17.
Oh, because you moved the 2. Or like,
Oh yeah, when
it doesn't matter.
0 squared is 0. So I just,
I was wondering. So we use that formula? The one we just solved for?
yes, because that's my h.
Okay.
That's your h of t. Negative 1/10 t equals negative square root of 17. The negatives go away, or I guess you can just leave it. What do I multiply the negative 1/10 to get t by itself? 10. Or negative 10. Make sure that it turns positive. It doesn't make any sense for t to be negative in this situation. T equals 10 square root of 17. And are these in seconds? Yes. Seconds. Oh, because 0 squared is still 0. But you could have you could have said, you could have done negative 1/10 t plus square root of 17 with a square on it equals 0. And then you could have done square root. What's the square root of 0? 0. So you could have put the square in there. Let's look at this rubric, guys, and then we'll call it a day. Do you guys like looking at the rubrics and all that good stuff? Okay. 2003, question 5. Okay, here it is. Yep. How many points for letter A? 3, and we got them all. Letter B. Look how many points letter B was. 5 points. Note that they do not give you a single point if you do not separate the variables. So yeah, you got to separate the variables. What's up? Depending on the type of expression, remember how sometimes if it looks a certain way, you can just say e to the whatever. So yeah, some expressions are easier to solve without. Yeah. All right, letter C. There it is. 10 squared of 17, guys. How do we feel? Do you like this? All right, we have a quiz win or a test win next week on Wednesday. Yeah, after the week. Oh, wait, mock exam this weekend. All right, guys, take care of business. You got work to do.